Today we are going to learn about Section 8 of Chapter 1 of Geometry. Our topic today is perimeter, circumference, and area. So our objective is to find the perimeter or circumference of basic shapes and to find the area of basic shapes. So if we look at this example below, you've got two friends. You're making wall decorations, and so you make the top decoration, they make the bottom decoration. Your friend says that your decorations are going to use the same amount of wall space, and you say that yours is going to use more wall space. Who do you think is right? So pause the video now and come to a conclusion about who you think is right. And so if we look at the actual space the shapes are covering, these shapes are actually covering the same amount of space. However, your friend's wall decoration is more condensed, so may appear to be taking up less wall space, whereas yours is more spread out. And so it appears like it's taking up more wall space, but each one of those shapes, if you add up all of their areas, you're going to get the same area as what your friend has. And so for today, perimeter and area, you need to remember that there's two different ways of measuring geometric figures. The perimeter, or P, of a polygon is the sum of the length of its sides. And the area, A, of a polygon is the number of square units it encloses. So perimeter is like if you were to walk along the outside of a garden. Area would be how much garden space you have, how much space is inside of it. And so many shapes have been used for thousands of years, and they have formulas that are already figured out for us that we can use. So make sure today that as we're doing these, if you can't remember these formulas, you're flipping back to this page in your notes to look at the formulas. So the first one we're going to talk about is square. And so a square has a side length of s, and so you can see a picture of a square there. The perimeter is 4 times s because all the sides are the same, and the area is the sides squared. Our next shape we're going to talk about is a rectangle, and that's got a lot of similarities to squares. The perimeter is 2 times the base plus 2 times the height. The area is just the base times the height. And so the area, remember, is the space inside. And then next one, we have a triangle. And so there's two formulas for the triangle. Perimeter is just the 3 sides added together. But to find the area, you need to know the base and the height of the triangle. And one key important fact is the base and the height of the triangle make a right angle. And so 1/2 times base times height will give you the area of your triangle. And our last formulas you need to know are circles. In a circle, we have a radius and diameter. Notice radius only goes across half the circle, but it goes through this center of the circle, whereas diameter goes all the way across from one side of the circle to the other, and it goes through that vertex of our circle. And circumference, that's if we were to circle it, we go around. And so our circumference has two formulas. It's pi times diameter or 2 times the radius. So depending on which one you have, you can use either formula. However, area you can only do using the radius. And so for some reason you have the diameter. If you take the diameter divided by 2, you're going to get your radius. And then you can do pi times radius squared to find your area. So now that we know our formulas, we're ready to find some areas and some perimeters. So one important thing you need to remember is that labeling your answers correctly is very important. When we're talking about perimeter, it's the distance around an object. So the units you're going to be using are inches, feet, yards, miles, centimeters, meters, kilometers. And when we're finding area, we're going to use measurements like inches squared, feet squared, yards squared, miles squared, centimeters squared, meters squared, because somewhere in your formula you're multiplying 2 dimensions together, which gives you square units. I had students who always said area, square area, and that's how they can remember it. And so our first problem here, we have a garden, alright, and so you have the botany club members are designing a rectangular garden for the courtyard, and they plan to place edging on the outside. So they're going to place some edging all along the outside of this garden. And so we need to figure out how much edging they need. And so if we think about this, okay, we're not given the actual dimensions of the outside of the garden, but we know that from here to here it's 16 feet. We know that the garden has this path has an edge of 4 feet, so it must be 4 here and 4 here. And so together, that entire side then, if we add all this up, we know that that whole side is 24 feet. And we can do the same process here on this other side. We know that from that smaller part is 22, and then we have a 4 and a 4, and if we add all that up, we get 30. And so our garden is 24 by 30. And if we're going to find the edging on the outside, we're going to find perimeter. And remember, if you remember our formula for perimeter, it's P equals 2 times the base plus 2 times the height. We plug those in. Our base is 24. Our height is 30. We get 48 plus 60 gives me 108. Now remember that 108 is not your final answer. It's 108. When we look at these labels, they were feet, and since it's perimeter, we're only talking about one dimension, so we're talking about just 108 feet. All right, so what you're going to do now is you're going to do the same type of process down here with this next problem. I would like you to draw a picture. I think that helps a lot, so pause the video here and do this problem. Alright, so now you can check your work with mine. I drew my picture, I put in some labels. I found that for A, the perimeter of the picture would be 24 inches if we're just talking about the picture, but the perimeter of the whole frame would be 32 inches. So, that's perimeter. If you got anything wrong, remember to go back, pause the video, check your work with mine. Alright, and so now we're going to talk about circles. And so, the symbol we see over here, this is the symbol for a circle. And a circle labeled with a D at the center would be called circle D. And so right here we would call that then circle D. And circle formulas, they always use this number pi, and pi is irrational. You've probably heard about it before, and what it really is, it's a ratio of their circumference to the diameter. So for every circle, the circumference divided by the diameter will give you pi. And so we approximate pi to be 3.14 or 22 over 7, but remember that neither of these are exact. For exact answers, we must leave pi in our answers. And so if we look at this website, here is pi to 10,000 digits, and so we can keep on scrolling down if you want to. It just keeps on going, and it even at the bottom it has dot 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 because it never stops. And so really we have computers have calculated pi to the 10 trillionth digit. That is a lot of digits. And so here we have some circle problems. What is the circumference of the circle in terms of pi? What is the circumference of the circle to the nearest tenth? So our two formulas, if you remember, are C equals pi d and C equals 2 pi r. So if you look at this first circle, we're given, it just goes from the center to the side, so that would be our radius, then equals 4 centimeters. So we're going to find this circle in terms of, we're going to use the second formula, 2 pi r. So we're using 2 pi r. R is 4, so 2 times pi times 4. That would give us 8 pi. And so in terms of pi, it's just 8 pi. And so now, if we're going to find our circle to the nearest tenth, we're going to use 3.14 today. And so we go 8 as our approximation for pi. We go 8 times 3.14, and we get 25.127 meters. So we put that label on both of these. We can do the same thing with this next one. If you look, that line goes all the way across. So what we're talking about now is the diameter. So we're going to use C equals pi times diameter. The diameter is 15, so we get 15 pi for our first answer. And using 3.14 as our approximation, we go 15 times 3.14. And we get 47.1 inches and 15 pi inches. And so that is what we should have gotten for our two answers on that one. So what I'd like you to do now is pause the video and do problem 2A and B. You can take a look at my answers. For A, I got it's 48 pi meters, and for B, it's 75.36 meters. If you got those wrong, pause the video, go back, take a look at mine. So here we have a triangle EFG, and it's in the coordinate plane. And so when we have something like this, we need to find those side lengths, and so we can use the distance formulas that we talked about. If we take a look at this side GF, the distance between G and F, well, that's going to be the difference of -3 and 3, which the difference of those would be 6. So that side length is 6. Take a look at these two sides over here. Okay, we go from 6 all the way down to -2, so that covers 8. Now it's this third side that gets a little bit tricky. On this third side, we actually need to use our distance formula. D equals the square root of x1 or x2 minus x1 squared plus y2 minus y1 squared. We plug in all those values, then we're going to call G.1 and E.2. We've got the square root of 3 minus -3 squared plus 6 minus a -2 squared. That gives us the square root of 6 squared plus the square root of 8 squared. That means the square root of 36 plus 64, which brings us up to the square root of 100. Make sure we have those equal signs because all these are the same, which is 10. And so this side length is 10. We can now add up those three side lengths. 6 plus 8 plus 10 is going to give us 24. And since we don't have a label given to us, we're just going to use units. And there you have it. So what you're going to do now is you're going to graph these 4 points, and you're going to find the perimeter of the shape. So I'm just going to graph them with you right now. Here we have point J, point K, then we have L, and then we have M. Oops, I put M in the wrong spot. M is all the way down here. And so finding 3 of these sides is going to be pretty easy. It's the side LM that's going to be a struggle. You guys can do it. So pause the video. Alright, here's what I got. I got 20 units for my perimeter of this shape. If you didn't get that, pause, check, make sure that your answers agree with mine. So when we're finding area, remember that you will be finding that you will be multiplying dimensions together. So now we're moving on from perimeter to area. They should have the same unit of measurement when you're multiplying them. And so I think area is a lot easier than perimeter some days. Here we have a banner. And you want to make a banner that's similar to it. The banner is 2.5 feet wide by 5 feet high. So remember, area equals just the base times the height. And so if the base of this is 2.5 and the height is 5, we go 2.5 times 5 to find the area in feet. But remember, they want yards, so we can find it in feet first. We can find it in feet first. It might be easier though to switch to yards right away. So we know that 1 yard equals 3 feet. So if we're comparing these, okay, so we have 2.5 feet, and we know that we're trying to get that into yards. So we know it's going to be less than 1 yard. So 2.5 is the same as 5.5. And remember, 5.5 feet, we know that there are, that in the 1 yard there are 3 feet, so we can actually write a ratio of 1 yard to 3 feet, and we can actually multiply these two ratios here. So we multiply them, then we get the feet cancel out and leave us with 5 6 yard. To do the same thing for 5 feet, we go 5 is the same as 5 over 1 feet times 1 yard over 3 feet. Our feet cancel out, leaves us with 5/3 yard. So now we go 5/3 times 5/6. That gives us 25/18 yards squared. Let's see if I can get that to fit in there. Yards squared, or 1 7/18 yards squared. And there you have it. Slide this out of the way so you can see that. So that's how much material you would need. So what I'm going to have you do now is do number 4. Now pay attention to number 4. They give you a poster in yards and feet, and they want to know it in square feet. So I'd start off with converting this 3 yards to feet. Remember, 1 yard equals 3 feet, which means that 1 foot is going to equal 1/3 yard. So pause the video. Alright, if we convert that 3 yards to feet, we get 9 feet. 9 times that 8 is 72, so we get 72 feet squared. Okay, so now let's find the area of a circle. We're going to try and move through this quickly. If we have the area of circle K in terms of pi, here's my circle right there. And so what I'm given right now is that measurement all the way across. Remember, that's the diameter. And the formula for the area of a circle is area equals pi r squared. And so we need to find actually out what the radius is, because the diameter isn't all that useful for us. And so remember, 2 radii make a diameter. And so we take 16 divided by 2, and that's going to give us 8. And so our radius is 8. So we can plug that in. Area then equals pi times 8 squared. Well, 8 squared is 64, so area equals 64 pi. And we just need to find that in terms of pi. So there you go. We're gonna skip this got it question, so don't worry about it. Skip on, move on to the next page. The next thing we need to talk about is when we have shapes that are irregular. So these are shapes that are composed of other shapes. And so there's a postulate we're going to use. The postulate says the area addition postulate. If you have a region, an area of a region is the sum of the areas of its non-overlapping parts. And so if I look at this problem over here, problem 6, I have this really weird staircase looking problem, this shape. And so what this postulate is really saying is that if I can find the area of these individual shapes, I can find the area of the whole thing. And so by using my congruent symbols, I know that this side is 3, this side is 3, 3, 3, and 3. Using that, I can now divide this up. Alright, we're going to divide it up into 3 rectangles here all the way across. There we go. Our first shape up here is a square. The area of a square, well, we know that that's it's the side squared, so that's 9. So we've got our first one. Now here I have a longer rectangle shape. We see that its height is 3, and its base, well, if we look up, it's made up of 2 squares. So this is 3 and 3, so it's 3 times 6, which gives us 18. Our third shape, we know that this side over here is 9 centimeters. It's got that congruent symbol to this side, so this must be 9 as well. So we take 3 times 9, we get 27. If we add all of these up, we get 9 plus 18 is 27. 27 plus 27 is 54. And remember, we're talking about area, so our label is squared, so it's 54 centimeters squared. Alright, what I'd like you to do now is to do this next problem. Pause the video, do it, and then check your work with mine. This is our last problem. Alright, and so if we do problem A up here, it says, what is another way to separate the figure in problem 6? There's a few ways you can do it. I see in here one big square we could have found, and then we would have had to do the 2 little squares. We could have just broken the whole thing up into little squares and found each one of those. Those are some different ways we could have done it. For our shape down here, I saw a rectangle and a triangle. So I found the area of my rectangle. 4 times 8 is 48. And then my triangle, I knew that this side here must be 4. So if I take 4 from 12, I get 8 for this side. And I see that these two make a right angle. So 8 times 4 divided by 2 is 32 over 2, which is 16. Add those up, you get 64 feet squared for your total area. So that makes the end of lesson 8 of chapter 1 of geometry.